So all of chapter 3 covers polynomial functions, and in lesson 3.1 we reviewed the one that we're most familiar with, which is quadratics, our x squared functions. So now we're going to talk about, well, what if the degree is higher? What if the exponent is higher? So just some characteristics of polynomial graphs here to start off with, just some writing and some visuals. So the graphs of polynomial functions are continuous. They don't have any breaks. They're smooth. They're rounded. There's no V shapes. One thing that I really stress when making a parabola is please don't make it look like a V. And so then that leads us down to what the graphs are not like. And so they're not broken apart. So a piecewise function is not a polynomial function. And here's that example of the V shape. They are not V shapes. That's an absolute value function. So polynomials are continuous, they're smooth, they're rounded, no breaks, holes, or gaps. And then graphs. So comparing to what we're familiar with, we're pretty familiar with the x squared parabola. And actually, any even function is going to be similar to that. So when n is even, the graph of that function, so n is the exponent, so when the exponent's even, it touches the axis and turns at the x-intercept. So it doesn't cross the axis, it doesn't go over, it turns and it goes back in the other direction. So that's if your exponent is even. And so the graph that they have here is the x to the fourth. So it's very similar to x squared, just stretched out a little bit longer there on the bottom. And then odd functions, so if your exponent is odd, then you are going to cross the axis. So notice here, our x to the third is gray. That's that like sideways S shape that we've talked about before. X to the fifth is similar. It's the darker one. It's a little bit longer on the axis, but it crosses over. So there's a relationship between even and odd functions and what the graphs look like. And so here's your x to the fourth function just shifted to the left one, right? X plus 1 means we're actually going a minus 1. So there's our new vertex. It bounces off, so it goes down, it hits the x-axis, but then it comes right back up. It doesn't cross. And here's x to the fifth, but reflected. So if we reflect that, it still decreases. It hits our x-axis, and then it crosses over. So some characteristics there. All right, so when we have larger exponents, there's more information in the graph. There's more places that it turns. It can increase, decrease, change directions. And so we're actually going to use Desmos quite a bit with what we do here. But the leading coefficient test can tell us a couple things about our graph just by looking at the leading coefficient. So whenever we have the leading coefficient, we want to make sure we have standard form. But if the leading coefficient is odd, if the exponent is odd, remember n is the exponent, so this is for an odd exponent, then two things could happen. There's two ways the graph could look because the leading coefficient could be positive. So in the first graph, you have a positive leading coefficient. In the second graph, you have a negative leading coefficient. So that's how this is broken down. So whenever you're asked to use this test, you're going to look and see, is it even or odd? And then is it positive or negative? So if you have an odd exponent here and you have a positive leading coefficient, your graph starts by having this downward arrow. So we say that it falls to the left. And then on the other side, it goes up, so it rises on the right. So that's the terminology that you'll see. So just by looking at if the exponent is even or odd, and if it's positive or negative for the leading coefficient, we can get an idea of the direction that the ends of the graph are going to go. So if your exponent is odd, but you have a negative leading coefficient, then you have where your graph is increasing on the left. So it rises on the left, and then it falls on the right. So notice they go in opposite directions. Okay, so then if your exponent is even, then we have our chart over here. So here we have an even exponent. then you can see both ends are going in the same direction, whether they rise or fall. So if you have a positive leading coefficient here, then you are rising on the left and you're rising on the right. Okay, everything in between, all of this stuff in between, this doesn't tell us anything about the in-betweens. It only tells us what happens on the left side and what happens on the right side. So just keep that in mind. And then if you have a even exponent and a negative leading coefficient, then you're going to fall in both directions. So you fall to the left and fall on the right. So some things you'll be asked is simply what happens on your graph? What's happening on the right-hand side and what's happening on the left-hand side? So let's go ahead and do some examples of those and use these charts to help us out. Number one, applying the leading coefficient test. Describe the right-hand and left-hand behavior of the graph of each function. So your answers are going to be, does it rise or fall? Those are your choices. And to do that, all you need to do is look at your leading coefficient in standard form. So for number one, letter A here, you have standard form, which is important. Our leading coefficient is a -1, so that's negative, and the exponent is odd. So we're going to look for our odd exponent, negative leading coefficient, and that will tell us what happens on the left and what happens on the right. So if we go to our chart, we have odd and negative. So that's this chart here, which means we rise on the left and we fall on the right. So our answer for letter A would be that this graph rises left and falls right. That's all that this question is asking us for. What happens? So that means that whatever the graph looks like, on the left-hand side, it's going to increase, and on the right-hand side, it's going to decrease. We don't know anything about this in between or what the graph is going to look like otherwise. All right, letter B, we do not have standard form. This should be our leading coefficient. So make sure you're focusing in on the term with the largest exponent. So you don't have to rewrite it in standard form. You just have to know this is what we're looking at to reference our leading coefficient test. So we have a positive leading coefficient and we have an even exponent. So if we look at our even exponents and a positive, we're rising in both directions. We're rising on the left and we're rising on the right. And then our last one, again, not in standard form. Here's the term we want to look at. So that's positive, and it's an odd exponent. So if we go to our odd exponents and we look at the positive, which is here, we fall on the left and we rise on the right. So just by looking at the first term in standard form, we can tell what happens on the ends of the graph. Again, this doesn't tell us what happens in between, but it tells us what happens on the left and the right sides.